Hey guys, so we're going to take and talk about some measuring tools today. First off here is going to be our tape measure. You can see this is a 12-foot tape measure, but it also has metric and standard on it as well. I will tell you guys that I call metric metric and standard I call it inches, and I'll call it imperial and a whole bunch of stuff here. So basically metric, the super easy one, and standard, the more complex one. Now with that, we also have some calipers. So this one here is an inch caliper, and this one is a metric caliper. What we're going to do is take and measure some stuff. I've got some various little parts here, and we're going to just go through and walk you guys kind of through how to actually measure stuff. Now I realize that several of you guys probably know how to do this already, and that's okay, but I would appreciate it if you guys would pay attention to the video anyway, because we're going to talk about some stuff that you may or may not realize, and I want to make sure that everybody's on the same page. So let's take and start here with looking at this tape measure. So first things first, you guys can see that we actually have inches on one side and we actually have millimeters on the other. And let me see if I can dial this in a little bit so you guys can actually read the numbers somewhat. So here we have our full inches, 3 and 4. You guys can also see we have our fractions like 1/2, 5/8, 3/4. But we also have these little tiny numbers here, a 9, 11, 13, 15. Okay, these right here are 1/16 of an inch. So they are a fraction. It's just, you know, they tried to write them in more of a shorthand. So 1/2, 8, quarters, and 1/16. Now, down here on the bottom, we actually have millimeters. You guys can see 90 millimeters, 100 millimeters, and in between is 1 millimeter per. Because there's actually 9 lines in between these, and that will allow us to take and count out to our next 10 millimeters. Now, if we come down here to the bottom, I want to point this out because I want to make sure you guys realize this. If you're taking and measuring here in metric, it's actually super easy. So if we're taking and doing millimeters, we can go 10, 20, 30. But if we're going to do centimeters, we can just go 1, 2, 3. Because there is 10 millimeters in 1 centimeter. Everything in this metric is based off of 10, which is super simple and easy. Let's take and measure this bolt. Now remember, when you measure the length of a bolt, we actually measure it underneath the head here. We're not going to measure it from the top. We're not going to hook onto it. We're going to take and measure from the base. Now, I do want you guys to notice here, while we're measuring this, that this little end here wiggles. And it does that on purpose because it takes into account the thickness of this piece of material. So when we go that way, it offsets it. And when we go this way, it offsets it again. So that way we can still use the same scale on the tape measure here, whether we're measuring up against something or hooked onto it. So make sure we're going to take and just push this right up against it, and we're going to measure this. Now when we zoom in here a little bit, notice that we're closer to the 7/16 than the 1/2 inch. So technically, this bolt here is about 2 7/16 of an inch long. However, okay, this bolt is 2.5. Because you don't take and measure parts like this, like a bolt, down to 1/16 of an inch. You measure this down to about 1/4 of an inch if you really wanted to. So really with this, we would just take and say, what is the nearest 1/4 of an inch? So it wouldn't be 1/4, that'd be way down here. The next 1/4 would be the 1/2, which would be 2/4. So we would call this a 2.5 inch bolt. And really what I'm trying to point out here, guys, is that when you measure stuff, you're going to change your accuracy depending on what you're measuring. So when we measure a bolt length, close enough to 2.5, let's call it 2.5. So if we took and we're measuring something, let's say this has to be really precise, then maybe we'll get down to a more precise fraction, or we'll get down into a decimal, and we'll get down into, let's say, thousandths or 10,000ths of an inch. If we were taking and doing something, let's say more like a ball bearing, like I have here, we would need something to be a little more accurate than a tape measure. But we'll talk about that in a moment. Now, that's our actual bolt here. And while we're here, I want to take and talk about these threads. Now, you guys can see that there's approximately an inch worth of thread here. So what we can actually do is just count our threads. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I counted 16 threads per inch. And that right there is going to be our pitch. So take note of that, guys. You may have to use it later, that when you count this out, we want to know how many threads per inch. Okay, when we're using our inch-based system here, our standardized system. Now, when we actually go in here and do metric, our other side, that's going to change, but I'm going to take and show you guys that later. We took and measured this at 2.5. Let's take and flip it over to the other side of the tape here, and let's take and measure this as millimeters. So what I'm going to do is look at that, and I think it's about to the 2 on that. So 62, we'll say. So on one side, we would call this a 2.5 inch bolt. On the other side, we would say about 62 millimeters. Let's take and switch over here and measure some other various stuff. Now, we've pretty much taken and used up here our tape measure, and I think you guys have the general idea of how to use this. So let's take and set it aside, and we're going to switch over to a caliper. So a caliper basically allows us to measure a lot more precisely. So let me show you guys how this works. So if we look at the scale on this, we have our 0, our 1, and our 2, and these are going to be our inches. Now, in between these are going to be tenths of an inch. Now, I know that's going to be a little bit different because we're used to our tape measure here that has our 1/16 of an inch. But the real reason that we're actually using our tenths of an inch here is that this is a decimal. So tape measure, we're measuring with fractions. Caliper, we're using decimals. Okay, so we have our whole inches. So let's say right here we're at 2. And then we would take and do point, and then our tenths place would be here. And then we have our dial, and our dial is going to give us a 2-digit number, and our 2-digit number is going to be our hundredths and our thousandths place. Okay, some things we need to actually take and talk about here. So let's take and zoom in here a little bit, and I want you guys to look at that 2. And you guys can see the line directly next to it. That line is very important because that's what we're actually measuring our 2. It's not on the number itself, but on the line. So if we're on this side of the line, we are less than 2. I know you can read the 2, but we are on this side of the 2 line, and therefore it is less than 2. We are at 1.9 something at this point. If we were on this other side of the 2, now we are at over 2. So it's 2 point something. Okay? So really watch these lines. So if we switch over here, let's go to the 7. Right here, we're at 1.7. Right here, we are now at 1.6 because we're on the opposite side of that little 7 line. All right, now let's take and get into our dial. So with this, you guys can take and see, one, we have our scale here, or our accuracy laid out for us. So as accurate as this is, it's going to be 0.001 inches in accuracy. So about 1,000th of an inch. That's pretty reasonable for a piece of equipment like that, down to 1,000th of an inch. And what we want to do is to take a look at these little lines right here, and then you can see the 20 and the 30, and we're right between that, and we're just about on to that 5 line. It's slightly bigger. We'll move it out of the way here. See if we can get a better line. There we go. Let's take and use this one down here. So we're at 4, 1, kind of right there between them. Try to put that right on something. There we go. We're right on the 1 line. So that would be 41. Now let's take and measure this completely. So if we look at it, we're at 1. We're past our 7 line, so that's going to be 1.7. And then we're going to be at our 4, or 40, and then 1 line past it, so that's going to be 41. So our answer here is going to be 1.741 inches. Let's take and write that down. 1.741 inches. Remember, our 2 hash marks right there are inches. And that's really what we're taking and looking at. Let's see if we can zoom in here where you guys can see without the glare, hopefully. We'll get our number in this shot. And we'll show you guys 1.7, because we're just on the right side of that line. 4.1. And that's our decimal right there. And that's how you take and actually read this. Let's take and actually measure something with it. We have this little nut here. Now these nuts, what we want to do is measure them from flat to flat. Don't measure it on the points. I don't know, unless you're directed to. But really you would want to measure flat to flat here. Now this will allow us to show you guys how to actually use this. So you can see our common jaws right here. Let's pull out where you guys can see a bit. We have our big jaws down here, and this will allow us to measure. Now normally you would measure right here on the tip. That's really the best way to do it. But I will say, so a lot of people will use the flats in between here to kind of hold flat-based objects. So for what we're doing, either one's fine. Just don't get so far in here that it's no longer accurate. We just want to be right in there. Now, real quick, while we're talking about it, I did want to take and point out, if I wanted to measure the inside of this, I would use these other jaws. And just to show you guys really quick here, we have the other end of this. Has this little thing that sticks out of the end and allows us to measure the depth of things. So I can stick that down inside of something and measure the depth. We're not really going to be using this one. I just want to show you guys that it's there. So really with this, let's take a measure flat to flat on this. Now what we could actually do is use some of our other various properties on here. So one, I can use that little wheel to kind of push up against it, nice and gentle like. Then I can take and use my lock here on the top to lock this in place. And that way, even if I pull this out, it holds my dimension on where I want it to be. Now let's take and actually measure this, and I'll write it down as we do it. So first off, we can see our 0. Maybe if I was in shot here. So on our 0, so that's going to be our first number, our decimal point, and then we're going to take, and you can see we're past the 5 line, but not quite to 6. So our next number here is going to be a 5. And then we have our caliper, and you can see we're at 50, we're past that 50 I think we're pretty close to that 56, so I'm going to count it. So we're going to say that that's 56 inches. So the width of this nut from flat to flat is going to be 0.556 inches. You guys can see that's pretty accurate. Now let's take and move on to our other caliper here, because there's some more things I want to take and show you. This one is metric. Now our metric here, if we look at it, we have our centimeters. And we have 1 centimeter, 2 centimeters. This thing goes on for a while. 15 centimeters, it looks like it does. But what I want you guys to do is to not think about this as centimeters. I want you guys to take and measure in millimeters, because I think it'll be a lot better to understand. So instead of counting this as 1 centimeter, I want you guys to count this as 10 millimeters. Okay, now each one of these lines between them, there's 9 lines between, so that makes up our full 10, is going to be 1 millimeter. So if we come all the way down right about there, that's pretty close. That's about a millimeter, 1 millimeter of space. Now we can take and actually get to our dial. If you guys notice, there's a 0 on the top and there's a 0 on the bottom. So what happened here is that the manufacturer that made this, they were like, how could I make this more complex and convoluted? And they were like, we'll give it 2 zeros. Double set. Really, basically, it just takes and allows you guys to take and do 1 millimeter on one side and 1 millimeter on the other. So if we come out here to 1 millimeter, we come halfway. That's 1 millimeter, and that's 2 approximately. About right there, 2 millimeters. And you can see we're on that 2 millimeter line. You can see that second little line there. That's our 2 millimeter line. So let's take and actually measure this so we can get some actual numbers to work off of. So we're going to take and stick this in. We're just going to hit our lock on it the same, just to kind of lock everything in place so that we can take and actually look at this. So if we zoom in here, you can see we're past the 1, so that's going to be 10 millimeters. And I've found the easiest way to do this is to write it out. So we're going to do 10 millimeters. That's our first. Now we can take a look at these smaller lines, and we have 3 of those past the 1. So that's going to be 3 millimeters. So 3 millimeters, write that down. Now we can actually look at our dial, and you can see that we are down to 0.1. So let's write that one down. So 0.1 millimeters. Now we really want to take a look at these little tiny lines between them. And this right here, this is where it gets complex. So make sure you guys are paying attention. These little lines are not 1. They're actually 2. And you can see that here. See how our accuracy on this is 0.02 millimeters. And that means that each one of these little tiny lines is 0.02 millimeters. So the fact that we're on that first one there, just pretty close to it, that means that that dimension is 0.02 millimeters. Now we can simply just add these all up. So we'll just do 10 plus 3 is 13. Terrible 3 there. Plus 0.1 and 0.02, which is 1 and 2. So that's going to be for the width of this nut from flat to flat is 13.12 millimeters. Let's take and talk about some other various aspects here that I want you guys to know. Sometimes these dials here are not super accurate, and I want to show you guys how to fix that. So let's look in here. I've got this pushed all the way in, and you can see we're not quite on zero. We're just a little off, a little bit. So we can actually fix that by adjusting this bottom dial here. So we want to release that little dial. And we can zoom in here where we can see what we're doing, hopefully without the glare. We can very gently turn that so we're right on the 0 line. And then just re-lock that in place. And that's basically how you calibrate this to make sure it's super accurate. Basically, when you take and move it in and out, it should take and return back to the 0, and it looks like it does. Some other various things that I want to take and show you. This right here is a metric bolt. So when we actually take and measure the threads on this, we're not going to be measuring threads per inch. We're actually going to be measuring threads per millimeter. Now, this can be kind of confusing, so I want to point this out to you. Because if we actually grab our metric dial caliper here, we can bring this up to 1 millimeter. Wow, that's as precise as I've ever been. So we'll call that a millimeter. We'll lock that in place. And that's kind of our dimension here on how we're going to take and measure these threads. Now, if you guys can see it, if we go basically between 2, we can really only effectively get 1 thread in there. So in theory, this is going to be 1 thread per millimeter. Now, that's not always the best way to do it, because we could have a weird number in there. We could have like 1.2 threads per millimeter. And the question here is, how would you even measure 0.2 of a thread? That's silly. So what we can actually do here is make this a little bit easier. And we're going to extend this out right here to 1 centimeter. Wow, that's like right dialed on. Wow, look at how accurate that is. That's cool. I did that completely by accident. We'll just call it I did it on purpose and move on. That sounds good to me. So now if we actually took and did this, if we tried to take and measure threads here, and you guys are welcome to stop the video and count these. Let me know if it is, but it should be 10 threads, because this bolt here is actually 1 thread per millimeter. And I did that on purpose so the math would come out now nice and easy. But there should be 10 threads in 1 centimeter. So if we have 1 centimeter measured out, that would mean that there are 10 millimeters inside 1 centimeter. And if this is 1 thread per millimeter, that means there should be 10 threads in 1 centimeter. So go ahead, guys, pause the video, count those if you desire, and let me know if there's in fact 10 of them there. But that's how you would take and actually measure the threads per inch, or say yes, the threads per millimeter, the actual pitch of the bolt. Is I would suggest pulling this out to 1 centimeter and counting those threads in there, and then converting into millimeters. All right, guys, let's take and do some other various calculations here, and let's try to see what numbers we actually get. So I'm going to bring back my ball bearing, and we'll just kind of push these other various parts out of our way. So this ball bearing is 3/8 of an inch. And I know that because I ordered it. And if we take and put this right in here next to a tape measure, and let's just attempt to bring this in and measure this. And if we kind of line that up, it's kind of sort of 3/8. But you guys can see this isn't really the best way to measure this. So we could take and call it 3/8. We could take and measure that from the other side here. 8, maybe? 8 millimeter? And something like that. Really what we'd want to take and do is to measure that with our caliper. And this kind of gets into using the appropriate tool for what we're doing. So if we're going to take and measure this with our caliper, we're going to stick this in here and measure that. And then we can take and actually look at this. So it's supposed to be 3/8 of an inch. So let's actually check it out here, and then we'll write down our dimensions. So our dimensions come out to, and I'm going to write them down here and then I'll show them to you. 0, because we have our 0. We're here past the 3 line, but we're not to 4. So 0.3. And now we're going to be at 7, and then that's going to be 4. Just before the 5th line. So it's going to be 0.374. Okay, I wrote that down right up here. Now, my point in showing you guys this is that when we actually do the measurements on here, we're doing 0.374, and that's the measurement that we got. But I know that this is a 3/8 ball bearing. So if we actually take on our calculator right here next to me and divide 3/8, then we actually get 0.375. So according to this, we're about 1/1000th of an inch off. But that's okay. When you guys actually do this assignment and measure some various stuff, you guys are going to get numbers that are ever so slightly different from each other and from the actual dimension of the part. That's normal. All of these various little pieces in here, though incredibly accurate, are always going to be ever so slightly different. And that's what we're looking for. Okay, when you guys measure these, I want you guys to write in exactly what the dimension is that you got. Don't try to round it. Don't try to make it better. If it's really, really close to 1/2 of an inch, but it's not, don't write 1/2 of an inch. Just like this, it's really, really close to 3/8, 0.375, but it's not. So give me that good answer there, the 0.374. That's what's important here. Hopefully you guys can kind of understand here of how to use these various pieces of equipment, whether you're using inches, millimeters, centimeters, fractions, decimals. Okay, try to be really accurate in your guys' dimensions. So try to get a good idea of how to take and use these tools appropriately. All right, guys. We will see you guys for the next one.